Okay, well, welcome everyone. This is the June meeting of the East Midlands Regional Group, so welcome everyone. Thanks for coming. Just as Mike says, we are recording it. We'll have questions at the end, so if everybody can just remain sort of muted while we've got the presentation on. And we'll have questions at the end. So tonight's lecture actually has a companion event, so that's our summer field trip, which is going to be to Castleton in the High Peak. We did advertise that as happening on the Saturday, the 25th of June, but we've had to revise that, so we've yet to finalise the new date, but it will be rescheduled over the summer, and we'll let people know. People, will need to book that. Of course, the numbers will be sort of limited to some extent. So, okay, on to tonight. So I'm delighted to introduce tonight's guest speaker, who is Dr. Peter Guttridge of Cambridge Carbonates Limited. Regulars amongst you will know that we like to celebrate our local geology, and this evening is no exception because Pete is going back to his roots and will talk about the demise of a carbonate platform, in this case the Derbyshire Carboniferous platform, here in the East Midlands. So just to describe Pete's background, he completed his PhD in carbonate sedimentology at Manchester University, and then joined Britoil as a production and well site geologist, working in the North Sea. He returned to academia for 5 years to continue his research on Denancionemirian carbonates, lecturing at Thames Polytechnic, where he taught all aspects of carbonate sedimentology, stratigraphy and petroleum geology. In 1990, he co-founded Cambridge Carbonates Limited, where he remains to this day as a director and well-respected consultant carbonate sedimentologist. Pete has worked on almost all the productive carbonate hydrocarbon systems worldwide. His particular expertise is in carbonate sedimentology, sequence stratigraphy and carbonate diagenesis, and his work mainly assists the geothermal and oil industries. So Pete, I can see you've got your presentation up and running, so I'll hand over to you to deliver your presentation. Thank you again.
Okay, thank you. Can everyone see my presentation? I'm going to be talking about the sort of last days of the Derbyshire Carbonate platform, taking the story from the Asbian through to the Nemurian. Now, while constructing this talk, it quickly became apparent that it's not just a story about carbonate sedimentology, but there's a lot of other things, as you will see, going into the story, and it expanded. I was forced to sort of expand the scope somewhat beyond the original scope of just talking about the demise of carbonate sedimentation, because there are many other factors involved. I'll just start off by putting it into regional setting. This is a overall paleogeographic map of the main Carboniferous basin in northwest Europe. Britain is here, the North Sea basin is here, Netherlands are here, and it's sandwiched between the Variscan orogenic belt to the south and the major Caledonian belt. So it formed as a back arc basin between the Variscan orogeny that was going on at the time and the remains of the Caledonian orogeny. And this is essentially a back arc basin. It's extensional, and we have carbonate platforms founded on a number of positive basement structures or attached to emergent basin areas. And the Derbyshire Carbonate platform was this platform in here. So it's right in the middle. Now, there were several extension events throughout the early Carboniferous and through to the late Carboniferous. And this caused reactivation of these basement structures, which caused localized areas of uplift and subsidence. And as we'll see, it created a different stratigraphy, different conditions of sedimentation during extensional and rift events. So this really is the fundamental control on stratigraphy. Now, to the north of the area, this was a major clastic source. We have a major Himalayan grade mountain range up here. And as you can imagine, that was a major source of clastics. And the main story, or a significant part of the story, is the gradual progradation of clastic systems through the basin, throughout from north to south, starting through the Denancionemirian with the Yoredales and continuing with the major clastic systems of the Nemurian. And I think an important part of the story is that this is a marine basin largely, but it actually has very poor connection to open oceans. And I think you can see evidence in the response of the carbonates to the fact that this basin is receiving a large volume of clastic sedimentation and terrestrial runoff. And I think you can see that it's affecting carbonate sedimentation. Now, start at the bottom. The basement of the Derbyshire carbonate platform is, I think, a key component of the sedimentary story. This is a gravity anomaly map. The black is the current outline of the Denancionemirian outcrop. And we can see the southern part of the Denancionemirian. The basement is relatively high and flat. But in the northern part of the Denancionemirian outcrop, there's a gravity gradient to the east, suggesting that the basement is tilted to the east, and there's a gravity gradient separating these two areas. And that eastward tilt is confirmed by the Woodale and Eam boreholes, which show that they encountered Ordovician basement in Woodale very shallow, Eam borehole relatively deep. So the northern part of the carbonate platform overlays an eastward dipping basement. Now, there's various studies by Leicester University looking at seismic refraction data between Charnia, the Charnwood Forest, and the connecting it through to the top basement reflector in the Derbyshire area. And they were able to demonstrate that they could follow the top Charnian basement through from its outcrop at Charnwood Forest, across the Widmerpool Gulf and underneath Derbyshire. So there's good evidence from geophysics and from actual real rocks in the Eam limestone and Woodale borehole that the northern part of the Derbyshire carbonate platform is underlain by Ordovician basement, and the southern part is underlain by Charnian basement. So this actually appears to be the margin of the East Midlands microcraton coming through here. Now, if you look at surface structures, there's a major fault complex called the Bonsall Fault going through the central part of the platform here, which has a progressive downthrow to the east. There's also as I'll show later on, there's an area of subsidence within the carbonate platform that appears to be controlled by these faults. And there's a cover structure to the east-west trending cover structure that also tends to control the intrashelf basin, this area of deeper water, which actually has no expression on the gravity map. So these are probably basement-related structures. That's probably a cover structure. So this is the general context. Now, to put it in a stratigraphic context, the BP onshore exploration group, when they were working around in the East Midlands area, they looked at the seismic stratigraphy, and they were able to develop a seismic stratigraphic based stratigraphy that they were able to relate to these extensional events during the basin evolution. And a lot of these major zone boundaries do actually correspond with rift events. So you can relate the stratigraphy at outcrop to the stratigraphy in the subsurface quite nicely. And the Derbyshire carbonate platform goes from syn rift clastics and evaporites of Corsaean age through to mid-Brigantian limestones deposited in a variety of carbonate ramp, shelf and intrashelf basinal carbonates. And then it's buried by basinal turbiditic, prodeltaic and fluvial clastic systems. So the part of the stratigraphy I'm going to be looking at in detail is the Asbian through Brigantian. So that's the Below limestones, Monsaldale limestones, Aeneum limestones, and then talk about what happens in the early Nemurian. And that corresponds with these EC5 and EC6 sequence stratigraphic events. Now, this is a brief summary of the paleogeographic evolution of the Derbyshire carbonate platform. Asbian, you had a uniform carbonate shelf. You had an extensional event at the Asbian-Brigantian boundary with differential subsidence intrashelf basin, and then you had a bit more differential subsidence during the Eam limestone, causing this intrashelf basin to expand somewhat. And just to place it in context with the key geographic areas, we've got Castleton at the northern margin, Buxton at the western margin, Bakewell here, Wirksworth at the southern margin, and Ashbourne here, and I'm about here. Okay, so if we start with the Asbian shelf carbonates, these show a very, very marked cyclicity. This is work by Walkden, who worked on shelf carbonates from a lot of the Denancionemirian of Northern England. He's worked on Derbyshire, he's worked on North Wales, and he found a sort of consistent sedimentological signature. We have this succession. The bedding planes are these clay bentonites, and these are often overlain by, these often overlie karst and calcritized surfaces. So many of these bedding planes in the outcrop here represent periods of emergence of the carbonate platform when the sea level dropped. Then, if you look at the succession through these carbonate cycles, you go, the transgressive phase is an intertidal phase where you've got deposition in between the tides. You then go into a high energy beach or shore face facies, and then a moderate to energy subtidal facies above normal wave base. And then you go into other high energy environment later in the cycle. So this has a very distinct signature whereby as soon as you go from emergence, you go straight into high energy carbonate platform facies. And that is a key indicator of the fact that I believe you're dealing with a healthy carbonate system here. The catch-up phase is very, very short. Now, what the catch-up phase means is that in a carbonate system, it always takes time for carbonate production to get started after, for example, a period of exposure. But in this case, it seems that as soon as the marine transgression came in, carbonate production was on it straight away. So there's very little in the way of a catch-up phase of carbonate sedimentation. So this is a healthy system. If we go and look at the different style of platform margin, this applies not just to Derbyshire carbonate platform, but to other Denancionemirian carbonate platforms of Asbian age. We have a very sharp, distinct margin. This is an example at Castleton, depositional dip of probably 45 degrees, dipping into the equivalent basinal facies. We've got a very abrupt transition from platform interior to platform slope. And we see this again at the southern margin. This is near Carsington, dipping to the south. So again, we've got a very steep margin, dipping roughly 40-45 degrees, made up of these bioclastic carbonates and also these microbial carbonates that probably produce the mud on site to stabilize the platform margin. The northern margin is accretional. You can see the transition between the shelf interior and the slope building up vertically, and the southern margin is, in contrast, progradational, so that's building out into the basin to the south in this case. So to summarize Asbian sedimentation, the carbonate platform is a flat top carbonate platform. It's essentially clastic free, and it's controlled by fourth or fifth order glacial-eustatic cycles. If you look at each of these cycles, there's a minimal catch-up phase to the shelf cycles. So carbonate production starts very quickly after exposure. This is symptomatic of a healthy carbonate system. And furthermore, the carbonate factory, that's the area which the maximum carbonate production takes place, which is usually within not more than a few tens of meters, occurs over the whole shelf during high stands. And in this case, we're surrounded by a typical high angle platform margin, which is appeared to be accretionary around the northern margin and is a progradational margin at the west and south. Okay, we now move to the Asbian Brigantian boundary. This is one of these extension events that affected the basin regionally. And this is where the carbonate platform starts to get wounded. One of the characteristics of the Asbian Brigantian boundary is a phase of deep karstification. I'm going to show you 3 examples. This is a very deep karst incision in the middle of the carbonate platform. You can see here we've got a deep karstic hollow, which if you follow up, there's a considerable cutout of the Asbian sediments with these Brigantian Monsaldale limestones deposited on top. This is along the Monsal Trail in Millersdale. Then I'm going to show you an incised karstic channel at the Asbian Brigantian boundary in the southern margin, and then move along to the western margin, where I've got some examples of what might be very dramatic karst developed along the western margin. Okay, starting off in the southern margin, we're here. This is in the town of Wirksworth. Now, I'm looking here north, in a northerly direction here, and I'm in the old quarry behind the BP garage. We see exposures of Asbian cyclic shelf carbonates here and here. That's the same face. I'm just taking the picture, stood over here looking that way. We have a very deep erosion cutting into the Asbian cyclic platform carbonates, and this is unlapped by Brigantian carbonates. Now, the morphology of the erosion suggests to me that we're actually looking at the margin of a channel that is cutting in a north-south vertical direction across the carbonate platform margin. Now, if we now take the upper picture and I turn around 180 degrees, we can look at a quarry face behind, an old quarry face behind us, and see what is infilling the channel. So this is the old car dealership in Wirksworth, if you're familiar with the area. So there seems to be a 3-phase fill to this channel. The lower part of the channel seems to be infilled with these undulatory bedded, thickly bedded, very coarse grained bioclastic grainstones with these concentrations of gigantoproductids at the base and grading upwards into crinoidal limestone, still very coarse. Then we have a second phase of infill where we see the same very coarse grained fascies, but we see these beds within it. So that actually seems to be a slumped unit. So I envisage this as a slump of as a slump of this very coarse-grained bioclastic material that's actually sliding down into the plane of the quarry face along this channel. And on top of that, again, we've got a third phase, which is this very thinly bedded, dark, fine-grained limestone interbedded with shales. And this occurs again as a series of slumped units that are sliding down this channel. Now, if we move to the western margin, there's a number of very interesting landforms that, in my opinion, have never adequately been explained. And it was only recent discussions with John Collinson and Brian Rosen that the sort of light went on in my brain. And we see here these very rugged outcrops of Park House and Crome Hill. And this is a view of Crome Hill taken from down here, looking at that margin. And you can see the dip in the limestone show that this is actually Asbian platform margin facies that has been very deeply eroded. And on the geological map, this has been onlapped by Nemirian shale. So we have a very deep phase of erosion that took place post-Asbian, pre-Nemirian. And I think we can actually narrow it down a bit further than that, because if we look back along the western margin, this is from various papers, the Buxton Memoir and various other stratigraphic papers. These have a series of erosional based outliers where we have Monsaldale limestone sitting in unconformable contact with underlying Asbian carbonates. So my proposal of this is actually we have a zone of tower cast of Asbian Brigantine age along the western margin of the Derbyshire carbonate platform, which implies that there's a tilting event to the east. Now, this, I have actually seen something like this before, and this is it. Just briefly go over to Mexico. We've got the Sureste Basin here, which is a Mesozoic basin surrounded by carbonate platforms. And if we look at the Artesa Mundo Nuevo platform, we've got a nice seismic line through it. And this is a mid-Cretaceous carbonate platform that appears to have been tilted to the south during the early phases of the Laramide orogeny. So what we've got here on seismic, we see a deeply casted, uplifted northern margin of the platform, and we have oil fields in the casted zone, Giraldus and Iris. And then we have a later late Cretaceous carbonate platform, sort of piggybacking on the tilted surface of the mid-Cretaceous carbonate platform. And we have fields such as Muspac and Catedral, which are more normal marine fields in rudist carbonates in this case. So to bring this back to Derbyshire, this is the casted western margin, and this is the Brigantian carbonate systems that are being deposited and onlap this tilted Asbian carbonate platform. Now, one of the consequences of tilting is that we get the generation of differential subsidence in the eastern part and areas of deeper water developing in the carbonate platform. At the same time, as the Asbian Brigantian, we see the development of this intrashelf basin that's structurally controlled, as I mentioned. This is a stratigraphic summary of the limestones deposited within the intrashelf basin. The grey or white ornament just refers to this general bioclastic limestones reworked from shallow water areas surrounding the carbonate platform, surrounding the intrashelf basin, and just deposited either by storms or turbidites within the basin. We also see some basin-wide coral markers. This is the Whitecliff coral bed, exposed just up here. And there are other coral markers within the intrashelf basin succession. And also we see a couple of very interesting and unusual laminated units. These are often dolomitized. There's the rosewood marble and the headstone laminite, which occurs at the Monsaldale Eam limestones boundary. And having just re-looked at these again since I've done my PhD, I now think that these represent episodes of palustrine or lacustrine deposition within the intrashelf basin. But what we also see is some progradational units, and the succession from the bottom of Monsaldale here up to the Whitecliff coral bed is in this part of the succession, and we see a gradual shallowing. So we see progradation of shallow water carbonates into the intrashelf basin. Okay. If we look at the, there's an interesting story told, I think, by the comparing the isopack of the Below limestones, which are Asbian, with the Monsaldale limestones, which are Brigantian. In both, these are both diagrams from Neil Aitkenhead's Buxton memoir. And I've drawn in the position of the Asbian shelf margin in this blue line on both cases. And I've just put in a few headline figures for the thickness. The Asbian limestones are 200 meters thick, the western margin thinning to 150 meters to the east. In dramatic contrast, the Brigantian Monsaldale limestones are 0 thickness around Buxton, and then they thicken dramatically to the east, 100 meters, 150, 200, and then we've got the bullseye round the Eam borehole where they're 300 meters thick. So the interpretation of this is that the Brigantian carbonate systems are onlapping the tilted Asbian platform in a sort of manner like this. So here's the tilted Asbian platform with the uplifted tower cast along the western margin. We're looking, I'm attempting to sketch out that part of the carbonate platform. So we're looking from a sort of southwesterly point of view. Now, I think this is where the basement starts to play a role. The major hinge line in the sedimentation seems to correspond with this gravity gradient in the middle part of the carbonate platform. And that is the transition between the Charnian basement and the Ordovician basement. So I think that is what is controlling the southern margin of the intrashelf basin, and effectively controlling the subsidence over the eastern side of the basin. And the surrounding carbonate shelf areas are sort of generating progrades into the basin. And I think the key thing is the northern margin of the basin, this east-west structure, doesn't have any basement signature. So I think that's just a rollover in the cover. Okay, if we now move to Brigantian cyclic carbonates, I think this is where the story really starts to develop, and from a carbonate's point of view starts to get a bit desperate. Now, if we look at the Brigantian paleogeography with the intrashelf basin, we only really see these Brigantian cyclic shelf sediments in the southern part of the carbonate platform. So the implication of that is the carbonate factory has actually been drastically cut in area, possibly by as much as 60 or 70%, which dramatically affects the ability of the carbonate platform to keep up with events such as sea level rise and so forth. And we also see a change in the cyclic nature of the cyclicity during the Brigantian. the transgressive unit is very different. We begin to see this development of condensed sedimentation. We have these biturbated clay-rich wax stones and pack stones with these shale-rich intervals appearing. And then we go up into this higher energy platform interior setting. So I think what's happening here is that the carbonate platform is beginning to struggle. There is a significant catch-up phase to the sedimentation. It is taking time to get going. And part of the reason may be increased subsidence due to the extension event, or to a dramatic reduction in the area of carbonate production over the platform. We also see a dramatic change in the nature of the shelf margins at this time. If we look at the southern margin, this is around Wirksworth again, so we're looking around here. This is a sort of block diagram of the facies. The Asbian platform margin is some 2 or 3 kilometers further out into the basin compared with similar Brigantian platform margin facies. So the carbonate platform system during the Brigantine has significantly stepped back during the at the Asbian Brigantine boundary. And what we see, we can see the actual platform margin facies association in Dale Quarry. This is a perfect quarry because it's now infilled. Fortunately, with Paul Bridges, we spent a day sketching the structures and published it in Mercian Geologist. And what we found is that most of the shelf margin facies is made up of this carbonate mudstone and wax stone with cherty material, and finally divided bioclastic material. So this is the general background sedimentation, just very fine-grained sediment winnowed off the platform and deposited from suspension over the platform margin itself. We also, in green, see these large-scale cross-bedded units. You can see one here that thins down here and is onlapped by these periplatform carbonates that make up bulk of the slope. So we've got a series of large carbonate sand bodies that are just being driven offshore driven basinward by storms, and they just stop when they run out of bioclastic sediment. But what we also see here is some very dramatic soft sediment deformation. This is now exposed at the top end of what remains of Dale Quarry, and that discontinuity there can be mapped all the way down the face right to the bottom, and that's several tens of meters vertical relief over several hundred meters of length. And unfortunately, these are all infilled now, but there's some very dramatic soft sediment deformations in that quarry face. So this platform margin was subject to a great deal of soft sediment deformation, which really reflects its position as a progradational setting. So sedimentation rates always high, very little opportunity for early lithification and so forth. If we move now to the northern margin of the Brigantian carbonate platform, this is the Castleton area. So Castleton's about here, Bradwell's about here, and what we see here is a very dramatic change along strike of the Brigantian margin of the carbonate platform. We have a very high relief platform margin over the Winnott's Pass, and there we have a very thin veneer of coated grains. So these are very coarse grained bioclastic sediment. We've got aggregate grains of ooids with themselves being coated and recoated. And what this indicates is that this is a very condensed environment. So this margin here around the Winnert's Pass area, above the Winnert's Pass area, during the Brigantian was probably a bypass margin with absolutely minimal minimal deposition on top of it. And as we go further along strike to the east, we begin to see a progressive thickening and change in the Brigantian carbonate platform margin. This locality at Pindale, there's some very prominent cross bedding in this in the quarry face. I did a paper with Rob Gawthorpe on Pindale and Hope Cement Works quarry at the time, and thank goodness he was one of Britain's top climbers in his prime, because he was able to climb up quarry faces like this and sample the rocks. So we were able to map out these sedimentary structures in the limestone. So we've got this large sedimentary structure developing vertically first, and then it builds up into an asymmetric structure with some large scale facets here, and then it's overlain by level bedded limestones. And we were able to show that the actual microfacies is related to the stages of the bed form. We see large volumes of microtized peloid bioclast grainstone, areas of marine cemented horizons, and these take place when in fair weather conditions where the bed form's stable. So there's no deposition, grains can get microtized, and the sediment can get cemented up. We also see intervals of bioclast grainstone where there's no microtization, and we attribute these to areas where the sediment has been reworked. So high sedimentation rates, high burial rates, no microtization. So this is the setting here. This is the line 2, where we've got this shelf margin carbonate sand body prograding offshore. Now it's worth noting that there are some volcanic events along here, and there's a couple of vents recorded along the northern margin. Further to the east, where the carbonates go into the subsurface underneath the Nemurian, there's a couple of old seismic lines shot up onto the outcrop, and these seem to show that the Brigantian margin here is very much progradational. So northern margin, we're going from a high relief bypass margin to low relief, hardly any Brigantian sedimentation, to a progressive thickening progradational margin of during the Brigantian. Now, one of the most interesting intervals in the carbonate in the succession is you get a proliferation of carbonate mud mounds at the top of the carbonate Monsaldale limestones, and this is the unit I spent a lot of time on during my PhD. Now, what I found was there's a systematic variation of the architecture of the carbonate mud mounds as you map them across the carbonate platforms. Mounds start off as small tabular mounds, then they grow into domical mounds, probably about a few meters relief, and then they seem to take two different pathways. You end up with a laterally extensive, laterally accreted complex, or you end up with a vertically accreted mound. And these laterally accreted mounds seem to occur in the more western, depositionally updip part of the Brigantian platform, and you get these vertically accreted mounds deposited in the eastern, towards the eastern part of the platform, and also out in the shelf margin areas. So this, I think, is a response of carbonate mud mound growth to sort of varying topography of the carbonate platform, where you've got a progressive deepening to the east. Now, where you get proliferation of carbonate mud mounds, that usually tends to start ringing alarm bells in the brain of a carbonate sedimentologist, because a lot of these are seen as drowning facies. And also, because these are attributed to the microbial production of carbonate of carbonates, these are usually associated with a symptom of excess nutrients in the system. And one of the hypotheses I'd like to discuss with any clastic sedimentologists out there is this a response to clastic input to the basin? So is there any sort of additional input of plastics or delta switching that happened somewhere in the basin at this time during the Brigantian that might explain this excess of nutrients? Okay, the Monsaldale Eam limestone boundary, we had a phase of emergence. We have areas of some of these carbonate mud mounds have got calcrete on top of them. Some have actually got Denantian caves. This is at the Stone Centre near Wirksworth. And we know that this is a Denantian cave because this brown area here is a speleothem deposit. And that speleothem deposit contains burial cements deposited during upper Carboniferous burial. It contains fluorite mineralization, and it contains bitumen residues. So this was forming in a Denantian cave. I also mentioned in the intrashelf basin, we had a sea level low stand where we had the deposition of lacustrine and palustrine carbonates. And these were probably fed by groundwater and by resurgences over the karstic carbonate platform. Here's some what I'm interpreting as freshwater tufa within the headstone laminite. Now we have a dramatic change of sedimentation style during deposition of the Eam limestones. Instead, there's no evidence that there's any cyclic platform carbonates that we've seen during the deposition of the Monsaldale or Asbian carbonates. What we've got here is a complete facies mosaic. And we also have the development of large-scale coarse bioclastic carbonate sand bodies. Here's an example from the Stone Centre. We've got some very large-scale cross beds of graded crinoidal limestones. These are part of a carbonate sand body complex with off-shelf transport directions to the south. In the central part of the Eam limestone formation, we've got a number of really interesting small quarries developed, which show this bioclastic carbonate grainstone, packstone facies with some really large carbonate sand bodies in them. Here's an example of what I've interpreted as a carbonate tidal sand ridge. This rose refers to these dipping beds here, and you can see that they are roughly perpendicular to the trend of the bedform crest. So most of the data is from this side, but there are some beds available for paleocurrent measurement just over here. This rose refers to small mega ripples climbing up the side of the tidal sandbar, and this rose refers to smaller scale sedimentary structures in the trough of these bed forms. Here's another example from the same quarry where we have this very large meter scale set with cross-bedded crinoidal grainstone alternating with layers of reworked gigantoproductids, showing a paleocurrent to the northeast. So we have a really complicated carbonate sand body here with complex sandbars, both longitudinal and transverse sandbars. And in the northern margin, we've already seen the progradational phase of the Brigantian platform margin there. Now, also associated with these, and a major part of the carbonate system, these are these gigantoproducted brachiopods. And these really seem to kick in as a major phase of the Brigantian carbonate production community. And the group at Leicester University and the BGS and Alessandro has done some really interesting work on the paleoecology and sedimentology of these gigantoproductids. And where between the sandbars here, you see this gigantoproducted facies almost universally over the carbonate platform. Now, if we think about that for a moment, what it means in carbonate sedimentology terms, gigantoproductids are adapted to live in high energy environments. They are kept in place by the sheer bulk of their shell, and they can keep themselves clear of currents and being buried just by the currents they generate around the shell. Also, if you can possibly compare these with modern creatures, you're probably looking at animals here that may be 50 or even 100 years old. Also, you've got high energy conditions all the way over the carbonate platform. There's no differentiation between high energy margin and low energy shelf interior, apart from the intra-shelf basinal area here. And what that, I think the message that is telling you is that the carbonate system is now really struggling to keep up with sea level change. There's no rimmed margin. It can let high energy conditions across virtually all the shelf, and it allows these gigantoproductids really are exploiting a niche of condensed sedimentation. So I think the carbonate platform is now really struggling. So what we want to look at now is the actual drowning process or drown events during the drowning of the carbonate platform. If we go back to the northern margin of the carbonate platform, these are the Asbian platform margin slopes here, and we have Winnett's Pass here, which is a gorge cut across the platform margin, and we have a very distinctive facies, again very coarse bioclastic crinoidal gigantoproducted grainstone packstone called the beach beds, which outcrops at Speedwell Cavern car park here. We've got this short section of it. Now, these have been suggested to have been a submarine channel deposit emanating from a Denancionemirian version of the Winnett's Pass. But I think Trevor Ford in his 1987 paper pretty thoroughly debunked the idea that there was any channel through the platform margin during the Denancionemirian whatsoever. And the Winnett's Pass is a Pleistocene runoff channel. Also, if you map out the beach beds, they actually onlap and therefore post-date the Asbian shelf margin. They also occur in the Castleton borehole drilled about here, and this is the succession I logged. At about 35 meters depth from surface, this incidentally is all Nemirian shale, so the Asbian platform and the beach beds are all onlapped by the Nemirian shale. We have a conformable top, and we go down into these coarse bioclastic grainstones, occasional shale partings, and occasional interbeds of bioturbated waxstone. So exactly the same facies we see at the surface. And what this shows is that the top to this is conformable. So we are in a drowning sequence. This is part of the drowning sequence. So what I think is happening is we had a very dramatic drop of sea level during the mid-Brigantian. So the shoreline was probably about this level. And when you drop sea level, carbonates will tend to go wherever the production's optimum. So you had this growth of this carbonate system in very shallow water, high energy conditions around the base of slope. And obviously at some point they are in a shore face setting. So bear in mind that these beds were first described in the 1890s as beach beds. And here we are 150 meters, 150 years later, and they probably really are beach beds. Okay, so if we had a sea level drop at that point, what was happening elsewhere up the carbonate platform? Now we have Treatcliffe Cavern section here, which that's the sketch interpretation by Simpson and Broadhurst, published in 1969. And we find we have a boulder bed on top of the, over much of this carbonate platform margin. We find that these, between the boulder beds, this is a photograph taken in the cave, where we've got Nemirian mudstone actually infilling the gaps between the boulders. So again, this is part of the drowning sequence. And if we go up top to Windy Knoll, which is beyond the skyline, we see exposures of the Asbian carbonate platform margin with deep karstic fissures in. So my suggestion is that mid-Brigantian, we had a major low stand with deposition of the beach beds, karstic collapse of the carbonate platform margin, and after that we get the onlap of the Nemirian mudstones. Now, if we look at the Denancionemirian Relationships, and these maps are compiled from the various memoirs, BGS memoirs around the area. The map on the left is the sub-Nemirian paleogeology. So if you stripped off the Nemirian and had a look underneath, this is what you'd see. Green is Nemirian conformable on Asbian, and this really corresponds to the platform margins at either side of the Derbyshire carbonate platform and the carbonate platform down here. White means conformable on Brigantian. Red means conformable, which takes place in the basin to the north and the west, and also corresponds with an area in the platform which corresponds with the intrashelf basin. The purple areas are areas of intra-Brigantian unconformity. If we now look at the pattern of onlap of the Nemirian, this is the western part of the carbonate platform, again compiled from the Ashbourne and Buxton memoirs. We see that the carbonate platform doesn't get completely buried until the Arnsbergian. So, and we get the greatest stratigraphic separation actually around the shelf margin. So there we've got Asbian through Arnsbergian stratigraphic separation. And if you look at the time, geological time scale, that, depending on which one you look at, that amounts to about 7 million years. And that's a long time for nothing to happen. If you look at the old papers by Hudson and Cotton about the Alport and Edale borehole, and if you look at the descriptions of the basinal sections in the Chapel memoir, you'll find that the Pendleyan to Arnsbergian basal Nemirian actually does contain distal carbonate turbidites. And these consist of benthic bioclasts such as crinoids, brachiopods, that have clearly been, there's somewhere producing carbonate even through into the Arnsbergian. And it's quite possible that carbonate production may have hung on in these sort of areas of the carbonate platform until the Arnsbergian. Okay, to summarize, during the Asbian, we have a healthy carbonate platform located over the entire carbonate platform. We have a period of extension at the Asbian-Brigantian boundary, where we have some tilting of the carbonate platform to the east. We have deep karstic erosion of the Asbian carbonate platform with tower karst developed at the western margin, and we have an initiation of the intrashelf basin. During the Brigantian deposition of the Monsaldale limestones, we have Brigantine carbonate systems that onlap the tilted and karsted Asbian platform. This tilting and the development of the intrashelf basin caused the carbonate factory to shrink perhaps by as much as 70%. And we have also increased subsidence after the extensional event, in which carbonate systems take longer to recover after karstic exposure. And the proliferation of carbonate mud mounds at the top of the Monsaldale limestones may be a symptom of input of terrestrial nutrients. During deposition of the Eam limestone, we have karst and calcrete development over the platform with lacustrine carbonates in the intrashelf basin. Deposition occurs as a facies mosaic, probably with carbonate deposition, condensed deposition over the carbonate platform, and carbonate production is progressively reduced and suffering from clastic progradation. Then we have a mid-Brigantian low stand with progressive drowning. We have karst collapse of the northern platform margin with coeval deposition of the beach beds at base of slope and upper slope boulder bed in the Castleton area. And late Brigantian to Arnsbergian are progressive onlap of the carbonate platform by marine clastic mudstone. Platform crest is finally onlap during the Arnsbergian, and carbonate turbidites in the Pendleton to Arnsbergian in the Edale Basin suggest that bioclastic carbonate production actually hung on during this 7 million year stratigraphic gap. So thanks very much for your attention, and I'm ready to take any questions.
Lovely, thanks Peter for that. That was great. Might actually sort of recognise some of these features when I go up into the Peak District next time. But yeah, so has anybody got questions? You can raise your hand on the, I think on the Zoom, or you can just start your video if you want, and pose your question, unmute yourself.
Hello.
Tony.
Yes, I don't know if you can see me. I can't see myself.
Yes, I can see you.
Thank you, Peter, for a very interesting talk. I was interested by the Middletondale anhydrite and also your tower karst on the west. Was the anhydrite deposited across the whole area, or was it just?
No, it's just in very limited basins.
Right. Okay. Well, that takes away my second question, which was, is there any evidence of dissolution of it associated with the tower karst and the karstification on the west side of the area? But if it was only deposited in the east, then that answers that question for me. So thank you very much for a very interesting talk.
Is Mike, have you got any questions? You know, normally.
No, I was just checking.
Can't hear.
We've lost you, Mike. We can't hear you. I can ask you a question, Peter. Obviously, a lot of what you've described is down to sort of the actual outcrops and what you can see, sort of interpreting these things. I think that came through a lot. If somebody plonked you down sort of in somewhere in Derbyshire, would you and didn't tell you where you were, would you be able to sort of, you know, is it that, you know, if you've got enough outcrop, can you sort of do you pick the story up, or?
Yes, but yeah. Yes, I think I could. I think this has also improved my sort of ideas about what's going on in the North Staffordshire Basin at the same time. So yes, I'm sure I could, but I've known this place for years, so that's probably not quite a
yeah. So do you rush off then when a new outcrop appears, like
not
behind
really,
the no?
no.
Yeah.
I saw a question on chat.
Ah, okay, yeah. What is the evidence that the Asbian Brigantian boundary is truly karstic and not simply erosional channels by, say, tidal currents? That's Andrew Fine.
The limestone is being eroded in a lithified state. We have clear evidence of dissolution that happens in the along the boundary, either on exposed limestone or by underneath the soil. So we have clear sort of Gordon Walkden first described the sort of mammillated surfaces, if you like, with these rounded landforms that can be. Sorry, got distracted by an email there. Yeah, so the geomorphological features of the surfaces at various scales show that these are being eroded in lithified limestone, and also there's also evidence that the limestones, particularly the Asbian shelf limestones, were eroded, underwent very early lithification.
Mike, are you back?
Can you hear me?
Yes,
Yeah.
we can hear you, yeah.
Great. Okay. My quick question, you were talking about perhaps increase in terrestrial input, given the nutrients that you saw arise in activity. What about the volcanic events? Because clearly basaltic ash can well be rich in nutrients. Does that tie in? Could that be related to increase in nutrients and increased biogenic activity?
I actually have a couple of slides that I debated whether to put in or not. One was about the volcanics, so I can quickly share that with you if that would help.
Please, yes.
The short answer is that the volcanics only happened over a very short period of time, either side of the Asbian Brigantian boundary. And in fact, they may actually have been locally beneficial to carbonate deposition, because there's an example in Millersdale where you go past a lava front, and there's evidence that it actually built a little mini platform over which you had shallow water carbonate deposition on top of it. So they were. I was debating long and hard to whether I should include the volcanic story, but it's very short-lived, and I don't think it really had any long-term effect on the carbonates sedimentation.
Okay, thank you.
Just another question, Peter. In terms of, obviously, there was a, like you were saying, that there was sea level drop significantly, and I just wondered how much sort of erosion and things sort of has actually happened in terms of, you know, how much of the story have we sort of lost? You know, I mean, you were saying about carbonate production carrying on. You know, essentially we've lost that. Is that true, or?
Well, one of the big problems is when you're looking at a limestone succession, probably most of what you're looking at only took probably 5% of the time to form. That picture of the Asbian shelf carbonates with the karstic surfaces, there's probably 90% of the time is probably located in the karst surfaces, and probably only 10% of the time is actually located in the limestone. So there's a lot we don't see, but it's difficult to know what to do with it, really. I'm sure there are sort of losses of data. I mean, we're just limited by exposure as well, so that's another sort of limitation.
Yeah. Okay.
Please, John Collinson. I just wonder, you're talking about the Parkhouse chrome area and so on in terms of sort of extreme karst. I just wonder to what extent you think there's undoubtedly some structural complexity, and I just wonder to what extent you think there's more of an interaction there between, I don't know, synthetic margin collapse almost relating to the tilting, and then your karstic superimposition on that.
I think that whole area needs remapping. I'm just I mean, I know you're thinking along the same lines, so and I think we need to get somebody out there to map it properly, and also look at the fabrics within the Asbian carbonates there, because if they've been exposed, there should be plenty of diagenetic stuff going on inside them that will be telling the story as well.
Yeah, I agree. I mean, I think that there is a scope for a lot of mapping. There's also a scope for some sort of section balancing exercises to go on through there, just to see how these different bits could possibly have fitted together.
Yes, indeed. I've been looking at that part of the geological map for well, ever since I was a PhD student, and just thinking, no, I don't understand it.
Yeah, I agree entirely.
Anyone else want to unmute themselves or put something in the chat? We've got something in the chat. What are the main organic sources of the carbonate factory? Crinoids, brachiopods, etc., or microbiolites?
In the Asbian, it's algae, crinoids, brachiopods to a lesser extent, but there's a lot of small jointed algae, small tubular algae that in the Asbian. The Brigantian, you seem to lose these phases, and it seems to be dominantly bioclastic. Crinoids, bryozoans, some microbial production, but I think that really is a key symptom of what's going on with the carbonate platform.
Anyone else? Last call. I think that may be it, Peter. So just like to thank you for obviously for you know, given you've got well, recovering from COVID as well. It's we're very pleased that you actually managed to make it tonight. So so thank you for that. And if everybody would like to unmute themselves, we can actually give Peter some applause, if that's okay with everyone.
Virtual applause. Thank you.
Thank you.
Thank you very much.
Many thanks.
Thank you.
Very
Thanks,
interesting.
Peter.
Yeah.
Cheers.
Thank you. Thank you very much.
Thanks.
Thanks. Yeah.
We should quickly say that there is a meeting lined up for July. I haven't got the details in front of me, but we will be emailing fellows in due course. And as soon as Lee said, as soon as there's information about the companion field trip, we will send that round. It's unfortunate the original date we fixed clashed with the BGS open day, which was announced later. So for various reasons, we had to pick a new date. So thanks again. Thanks to Lee for organising it, and Peter. Very, very interesting. An awful lot to think about.
Okay, thank you.
Great, lovely. Thanks, Peter.
Thanks.
Thanks,
Great.
Mike.
Yeah.
Thank you.
Yeah, bye.
Bye, everyone.
Everyone.
Bye-bye.
Bye.
Yeah.